Here is another challenge problem on similar triangles. Question 9. For the diagram, CD is parallel to BE. That means CD is this line. CD is parallel to BE, which is this line, right? So these two lines are parallel, and AG is parallel to EF. So AG and EF are parallel, so we can write this as these arrows. Actually, these arrows indicate parallel lines. Now find the value of x and y. So that is the variable x, and this is the variable y, which we need to find. Part 2 is find area of triangle ACD, this triangle, given area of triangle ABE, the small one, as 32 centimeters square, right? So this question is very interesting and very helpful. It will kind of review all what you have done so far in similar triangles, right? So let's first see whether these two triangles which we are talking about, there are a couple of triangles here. So the variables to figure out are x and y. If we consider this triangle, then we have two variables. If we consider triangle ACD, we have only one variable. So it is better to start with triangle ACD and ABE. So let's consider the triangle ACD and triangle ABE. Right? Since we are given that these two lines are parallel, that means their corresponding sides should also be equal, correct? So that means this angle is equal to this angle, correct? So these two angles are equal. Why? Because these are parallel lines and AC is a transverse line. So these are corresponding angles, correct? So we can write angle C is equal to angle B. And the reason is that they are corresponding angles. Correct? So we know that. And second, if we consider these two triangles, then we know angle A is common, right? So angle A is equals to angle A, right? So which is common, right? So because of AA, we can write these two triangles as similar, correct? So we write triangle ACD is similar to triangle ABE, and the rule is because of AA property, correct? So angle-angle property of similarity. Now since these two triangles are similar, then their corresponding sides should have a fixed ratio, correct? So we'll use that ratio now. So we have proved that this is a common angle. Now unfortunately we have both the sides opposite to this angle given to us. Now for this angle the side opposite is 12, and for this angle side opposite is 12 plus x. Do you see that? We need to find x, so we'll write that first. So we can write 12 plus x, which is side opposite angle C. 12 plus x over, in the small triangle opposite to this is 12, is equals to, if we see with this A angle, in the big triangle it is 9 and small is 6. 9 over 6. Correct? Now solving this, we can always find the value of x. 9 over 6 can be simplified as, we can divide both by 3 and get 3 over 2, right? So we get 12 plus x, okay, 12 plus x is equals to 12 times 3 over 2, right? Or it is equals to 18, correct? 12 times 3, 36, divided by 2, 18. Now we can solve for x. So x is equals to 18 minus 12, which is 6. So we get the value of x as 6. So we know this side for us is 6, correct? Now that will help to find the value of y. Now let's consider the triangle ADG and EDF, right? So let's consider the triangle ADG and DEF. So we see triangle ADG and triangle EDF. Now in both these triangles, what we see is, I'm not writing all this, but you should write, okay? We see that angle D is common angle. So one angle we have identified as common. Plus we know that these lines are parallel. since these lines are parallel, their corresponding angles should also be equal, right? So this angle is equal to that angle, correct? So angle F is equal to angle G. So from AA property, so we know F and G are equal because they are corresponding angles, right? So we can write this as corresponding. And these are common angles, right? So these are equal, and therefore we can write that these two triangles are also similar, right? Since they are similar, ratios of the sides will be constant. And now we need to find y plus 2. So we can write this as y plus 2 divided by 4 is equals to, in big triangle, this side is 12 plus 6, 18, right? 18 divided by, in small triangle, it is 6. And 18 over 6 is 3 for us, correct? So y plus 2 is equals to 4 times 3, 12. So we can write y plus 2 equals to 12, or y is equals to 10. So we get the value of y, which is 10. So this side is 10 plus 2, correct? So we got our sides. That is, part 1 is done for us. Now part 2 is find area of triangle ACD given the area of triangle ABE, right? Now, one thing which is very important to understand is, so I have very limited space, so I'll explain you in this space, that in similar triangles, if the side ratio is k, then for areas the ratio is k square, right? Because for finding area, two sides get multiplied. So k times k will give you k square, right? So now, if you see the area of big triangle to area of small triangle, it should be square of their sides, correct? So we can compare the sides, 9 over 6, which is here, 3 over 2. So 3 over 2 is ratio of their sides. So ratio of their area should be 3 over 2 square. So k constant is 3 over 2 for us, right? So square of this will be square of this, which is 9 over 4, right? So area is 9 over 4 times the area of small triangle. Therefore, we can write area of triangle ACD is equals to 32 times 9 over 4. Do you get it? So when you do that, 32 goes 8 times, and 8 times 9 is 72. So we get 72 centimeters square as our answer. Correct? So I've done all this in short, but I'd like you to write all the steps and solve this problem on your own. It is a good practice problem for your test, right? Have a good look at it. Thank you and all the best.